Hi, I'm Mr. King. Today we're going to focus on section 6.4 from our Inside Algebra program. And today's lesson is compound inequalities and inequalities involving absolute value. Before we really get into the work today, I want to focus on some key terms that are crucial to our mastery of the content that we're covering in this video. So let's take a look at some definitions. First, number one, a compound inequality. That is when you have two inequalities connected by the words and or. Compound inequality. Number two, the term and. When you see the word and in an inequality, you must have all conditions. All conditions must be true for the statement to be true. You'll see as we move forward, you'll see how this comes into play. All right. If we have and, we also have or. Or is used in the following manner. If either or both condition is true, the whole statement is true. Okay. And our last term for today is absolute value. Absolute value is defined as the distance a number is from 0 on a number line. Absolute value is always written as a positive number, and the symbol for absolute value are two parallel lines. Okay? So let's take a quick look at an example of absolute value. The absolute value of -6 is 6, and it's read as the absolute value of -6 is 6 because -6 is 6 units from 0. So again, absolute value is a number's distance from 0. That's all it is, and it's always in a positive term. Okay, let's move forward. Now, we're going to work on solving and graphing compound inequalities. We're going to do it by looking at two examples. Example number 1. 3x minus 4 is less than 17. There's that word and that we discussed in our terms. And the second inequality is 5 minus 2x is less than 1. So here's how we approach it. We are going to solve this first inequality. Then we're going to solve our second inequality. We're going to graph them separately, and then we're going to graph and see how our answer plays out. So let's go through this. 3x minus 4 is less than 17. From our previous work, we know that to solve, our goal is always to isolate the x and get it by itself. So we're going to go through the process as we have done for the last few weeks. We're going to subtract 4 from both sides. If you subtract 4 from 4, they cancel out. That is gone. You're going to subtract 17, take away 4. You're going to have 21. Our last step is we now have to isolate the x by eliminating the 3. The 3 is a multiplication there, so we're going to divide both sides by 3, and our final answer is x is less than 7. We come down to our number line. We find 7 on our number line. It's an open dot because it does not include the 7, and we draw our graph facing in the negative direction. Okay? We come over to our second problem, and even though it starts with a 5, we know that we can solve these problems. So we start to, again, our goal is to isolate and get x by itself. So we subtract 5 from both sides. If you subtract 5 from 5, they eliminate each other. They undo each other, as we talked about in previous times. We go to the right-hand side of the inequality. We have a 1. Take away 5. We have a -4. We then have -2x is less than a -4. It's a multiplication. We know again that we're going to eliminate the multiplication by doing division. We do that on both sides. But we also have one more thing we have to be concerned with. We are dividing by a negative term. So what we have to do is we flip our sign the opposite way. We then take -4 divided by -2 and get a +2. One thing we want to really be focused on here is you don't want to do all the work that you're doing here. You could do everything correctly, but if you fail to flip your sign because of negative numbers being involved in the elimination of any coefficient that goes before our variable, you will do all that work and you'll make a mistake that I know that you can do correctly. We don't want to come that far and make that mistake. So we're going to graph x is greater than negative 2. Here, excuse me, x is greater than 2. We have an open circle at 2, and we graph it this way. Now remember, we had the word and, the conjunction and, which means we're going to look at two criteria for our graphs here. So look, we are going to graph the x is less than 7, which is going in this direction. We're going to graph our x is greater than 2 and graph it going in this direction. And therefore, this is the solution of our compound inequality. All the numbers between 2 and 7, but not including 2 and 7, will satisfy this compound inequality. So remember, earlier we talked about 3 dots means therefore. Therefore, the solution includes numbers that must be between 2 and 7. If you put 4 in here, 3 times 4 is 12. 12 minus 4 is 8. 8 is less than 17. That works. If we put a 4 in here, that is 2 times 4 is 8. 5 minus 8 is a negative 3. Negative 3 is less than 1. That solves it. So these are the only numbers that would satisfy this compound inequality. Let's move on. Let's take a look at an example here. Now this time we're going to go with our conjunction or. Okay? 2x plus 7 is less than or equal to 13, or 5x minus 19 is greater than or equal to 16. Once again, what we're going to do is we're going to graph each inequality separately, and then we're going to merge it and find the solution that would satisfy the entire compound inequality. So we go back to our first one. 2x plus 7 is less than or equal to 13. Subtract 7 from both sides. We get 6 on this side. The 7 is eliminated. You had 2x is less than or equal to 6. We cancel by dividing by 2 here. 2 goes into 6 3 times. So we graph this. The graph of this inequality is x is less than or equal to 3. We put a closed dot here at 3, and since it's less than, we're going to go in the negative direction. So all the terms that would satisfy this inequality would be from 3 to in the negative direction, but this time they include the 3. We now graph 5x minus 19 is greater than or equal to 16. We solve it first, and then we'll graph. We add 19 to both sides to cancel out here. We get 5x is greater than or equal to 35. 5 goes into 35 7 times. So now we have greater than or equal to. So we come to 7, a closed dot. We're going in the positive direction. Okay? Here's what we know now. Notice we are looking at a section that is really eliminating some possible solutions here. This gap between 3 and 7 are the only numbers that will not satisfy this compound inequality. So we're actually going to go in both directions. So what we have therefore is a solution that must be numbers equal to or less than 3, which is going this way, or they must be equal to or greater than 7. So since we have a restricted solution here, let's check some of our answers. So we're going to go back to our initial inequality. We'll pick one of the terms that's going to the left in the negative direction here. We're going to put 0. 2 times 0 is 0. 0 plus 7 is 7. 7 is less than or equal to 13. That satisfies this first inequality. Let's look at the other one. We're going to put 10 in here. 5 times 10 is 50. 50 minus 19 is 31. 31 is greater than or equal to 16. So we have a correct graphing and we have a correct solution to this inequality involving the term or. Okay? Now here's what I'd like you to do. I have 2 practice problems here. I would like you to solve these 2 problems, and by doing so, I really like you to turn off the tape Solve them as we did the previous one, where you're going to solve both of them and graph them. Turn the tape back on when you're ready to check your answer, and we'll go over the solution. Okay? So take a few minutes, remembering that you wanted to be in this form here. You want to solve it, graph it, and then put them all on one graph so that you can see if it's restricted, where it goes in two different directions, or if it is one that is inclusive and you have everything coming between the 2 points that are plotted. Okay? So take a few minutes, do it, turn the tape back on. Okay, welcome back. Let's check the answer to these inequalities that are written as compound inequalities. The problem was x plus 5 is less than 8, or negative 3x is less than negative 18. As we solve it, we eliminate the 5 on both sides and subtract 5 from 8 and get 3. Our graph initially, the first graph of x is less than 3, you have an open dot at 3, it's going in the negative direction. Okay? We now have negative 3x is less than negative 18. Divide both sides by a negative 3. Remembering, if we divide by a negative, we must flip our sign. If we flip our sign, we now have x is greater than 6. We graph it this way, with an open dot going in the positive direction. And what we now see is that we have a restricted graph where we are going to the left from 3 and going to the right. So our solution is x is less than 3, or x is greater than 6. Now let's look at our second problem. Our second problem was 4x minus 3 is less than 17, and 2x plus 9 is greater than 13. This one has multiple steps, so first we have to eliminate the numbers by adding 3 to both sides. We have 4x is less than 20. We divide both sides by 4. We now have x is less than 5. We come over to the second inequality. 2x plus 9 is greater than 13. Subtract 9 from both sides. We have 2x is greater than 4. We divide both sides by 2. We have x is greater than 2. As we graph this, we're going to say x is less than 5. So you have an open dot at 5 and you're going in the negative direction. You have x is greater than 2. You have an open dot at 2 going the positive direction. And that is why we're looking at only the numbers between 2 and 5. Those are the solution to this. That is the solution to this compound inequality. And that's why it's written here. X is less than 5 and x is greater than 2.